This is section 7.5, strategy for integration. So they provide us a table for integrating. There's different formulas that you can use freely. In the previous section, we use this one. This is where I was mentioning that there's a formula for the integral of secant. So there it is. But you can use any of these. It's all fair game. This one comes up pretty often or sometimes. All right, so let's look at some strategies. First thing you should do is simplify the integrand if possible. Look for obvious substitutions, and then classify the type of integral, whether it's a trig function or rational or integration by parts or radicals. So it's just a matter of, it just comes with experience. Doing enough of these, you'll figure out what type of integration is necessary. So for this one, it looks like this one smells of a substitution. So what I'm inclined to think is that u would be cosine, and then we save a sign, and so when you differentiate, you'll have that sign, and then you can substitute. So this is what I mean. Let's rewrite this integral as sine squared, and then we'll save a sine x for the side, and on the bottom it'll be cosine x. And of course we have dx. So this is what I meant. Our u will be cosine x, because when we differentiate, we get negative sine of x dx. And there's the substitution that I was referring to. We don't want the negative, so I'm going to move the negative to the opposite side by dividing by -1. So now we can go ahead and substitute in for that. And then u, this becomes u, and this can be written as 1 minus u squared, because we know that sine squared x is equal to 1 minus cosine squared x. So that's an identity we're going to use. All right, so let's rewrite the integral as the integral of 1 minus u squared. That's because sine squared became 1 minus cosine squared, but cosine is u. So that's where I'm getting the u squared, 1 minus u squared from. The denominator is u, because that's our cosine, which is u. And then this gets substituted out in place of negative du. And so there's our new integral. What I'm going to do is I'm going to split this up into two separate fractions, this way, and also distribute the negative. So if I do that, I'm going to get negative integral of 1 over u plus, well, that's with respect to u, plus the integral of u squared over u, which is simply u. The u squared divided by u is u, and it becomes plus because when you distribute the negative, that becomes plus. All right, and this is a straightforward integral. That's going to be negative ln absolute value of u plus 1/2 u squared plus c, constant of integration. And of course, our final step is to resubstitute cosine x in for u. So that will do it. It's going to be negative ln of absolute value of cosine of x plus 1/2 cosine squared of x plus c. That is our final answer. Let's look at the next example. This one reminds me of section 7.3, trigonometric substitution. So if you want to refer back to your notes, you will see that anything of the form a squared minus x squared under a radical, they're going to want us to use the substitution x equals a sine theta. So a, because a squared equals 1, there's our a squared is 1, therefore a is also 1, if you take the square root. Therefore, a sine theta is simply going to be sine theta. The a is just 1. We don't need to write it in. And when we differentiate, we get dx equals cosine theta d theta. And now doing the substitutions, we can rewrite this integral as x squared becomes sine squared theta. The denominator becomes 1 minus sine squared theta. Dx becomes cosine theta d theta. All right, so similar to what we did above, we're going to use this identity to replace this for cosine. So it's going to be the integral of, let's see, this is going to be, the denominator, well, sine squared can stay the same. The denominator will be square root of cosine squared theta, cosine theta, d theta, and this is going to be cosine theta, which we can then just cancel this out with this. All right, our limits of integration are going to change because we're doing a substitution. So we have to plug in 0 in for x and determine what theta is. So that shouldn't be too hard. Hopefully that's 0 equals sine theta, which means theta will equal 0. And for the upper limit, if you substitute radical 2 over 2 for x, you're going to get, from our unit circle, we know that theta, sine has a y-coordinate of radical 2 over 2 at pi over 4. So those are our new limits. So 0 to pi over 4. And if you recall from that section 7.3, there is an identity that we're going to use. Sine squared theta is equal to 1/2 1 minus cosine 2 theta. So that's the identity we're going to use in order to solve this integral. So now we can rewrite the integral as 1/2 1 minus cosine 2 theta d theta. And now the antiderivative will be theta minus 1/2 sine 2 theta. And once again, we don't have to plug in the bottom limit because when you plug in the bottom, you're going to get 0 minus sine of 0, which is 0. So this is just going to become 0 for 0. So we only need to plug in the top limit. So if we do that, we're going to get pi over 4 minus 1/2 sine. When you plug in pi over 4 here for theta, you're going to get pi over 2, which is 1. So that's just 1. So 1 times 1/2 is 1/2. So we can go ahead and distribute the 1/2, and our final answer will be pi over 8 minus 1/4. That is our final answer. All right, let's look at the final problem in this section. This one looks like a problem, an integrand that can be simplified. This integrand can be simplified. So let's just focus on the integrand for now. Sine theta cotan theta over secant theta can be rewritten as sine theta times cosine theta over sine theta. That's the definition of cotangent, divided by 1 over cosine theta, which is the definition of secant. So as you can see, these signs will cancel. When you multiply by the reciprocal, that's going to be cosine squared. All right, so now our integral is going to be simplified to simply cosine squared theta with respect to theta. And we're going to use an identity that says cosine squared theta is equal to 1/2 1 plus cosine 2 theta. That's the identity we will be using for this problem. So our new integral will now become 1 plus cosine 2 theta d theta. Okay, so the antiderivative will be theta plus 1/2 sine 2 theta pi over 6 pi over 3. Let's plug in pi over 3 first. And then we'll plug in pi over 6 next. So let's focus on these two expressions. The sine of 2/3 pi, that is radical 3 over 2. And similarly, sine of pi over 3 is also radical 3 over 2. You can verify that on a unit circle. And notice that this term is equal to that term. And since we're subtracting, when you distribute the subtraction, this will become negative. This is positive. So that means that these two terms will just cancel out. So we'll be left with negative pi over 6 here, positive pi over 3, and 1/2. So I'm going to go ahead and distribute the 1/2. And our final answer will be pi over 6 minus pi over 12. And if we find our lowest common denominator, times 2, that would make 12. We're going to get 2 pi minus pi, which is pi. So pi over 12 is our final answer. So that is how you would approach these problems that involve integrals.